Hey guys, I'm Tiffany from Miss Bouget's Period 3 class, and I'm going to do a question on power, and we're going to focus on number 6. So, a 1400 kilogram car is traveling on a level road at a constant speed of 27 meters per second. The drag force exerted by the air on the car and the rolling friction force exerted by the road on the car add to a net force of 680 newtons, pointing opposite the direction of the motion of the car. A. Determine the power due to the work done by this opposing force during this process. So let's first write our givens. So this is number 6. It tells you that the mass equals 1400 kilograms. The velocity equals 27 meters per second. And the force, the drag force on object, and the object's a car, is 680 newtons because it's already added up together. Okay. And this force is opposite the direction of the car. And that's going to be relevant later because you have to use cosine 180. So let's first start with our equation for power, which is work over time. And work is mg cosine theta times your displacement. And mg is just force, all divided by t for work. So power equals m, you know because it's a given, 1400 kilograms, g, 9.8 meters over second squared, cosine 180 because it's opposite, and then change of x over change of t. And the equation that you need for this problem is to know that change of x over change of t just gives you v, velocity. So because they're not giving you the change of x or time, you would just have to substitute this equation and use that. So power equals 1400 kilograms times 9.8, the force of Earth on object, cosine 180, which is just -1, and then you would just cancel those out and add and multiply by velocity. And then same thing, and then velocity they give you is 27 meters over seconds right there, and that's part of your given. And then you multiply that all out in your calculator and you get negative 18,360, but power can't be negative, so it's basically absolute of that, which would be 18,360 watts. And they ask you for your answer in horsepower too, so you would just divide it by 746, because you know that 1 horsepower equals 746 watts. And after you calculate that, your answer would be 24 horsepower. So these two are your answers for A. And then B, you know, theta equals 4. Oh, we didn't read it first, okay. So B, the car instead drives up a 4-degree incline at the same speed. Determine the power due to the work by the opposing friction-like forces and the force exerted on the car by Earth during this process, expressed both results in watts and in horsepower. Okay, so we know that power equals the force, the drag force, so drag force on object plus the force of the Earth on object, and then change of x all over change of t. And that power, you already found this in your last question, so we're just gonna, well, that was given, so 680 newtons. And then we're gonna add the new force, mg, and since it's at an angle, you're gonna have to do sine 4. And then for work, it's always force times your displacement with your angle. And then for power, you always need to divide by T. So then X and T cancel again. So let's just plug in everything we know. Mass is the same, 1400 kilogram. Sine 4. And then V, because X over T equals V. Same thing as what we did before. Therefore, power equals, you plug that all in your calculator, and you get 44,199 watts. And then you just divide that number by 746 to get 59 horsepower. So both 59 and 44,199 watts are your answer, because they're asking you to find both horsepower and watts. So that's your answer for power for the second one, and that's your answer for the first one. So this is an overview on number 6 from power. Hope you guys were reinforced on the topic of power. That's all. Bye.